Sample problem 2.5. Deduce the formulas of the following ionic compounds: mercury 1 chloride, lead 2 chromate, and potassium hydrogen phosphate. Okay? So we're going to go backwards now. We're going to go from the name of the compound to the formula instead of going from the formula to the name. So let's start with the first one. The first one is mercury 1 chloride. Okay, so you have to figure out what the symbols of the elements are that we're talking about here. So what's the symbol for mercury? I think that is. Look it up in the periodic table. Look for mercury. Mercury is element number 80. 80. And if you look it up, you'll see that it's Hg. Isn't that cool? Hg. That's mercury. Now look up the symbol for chlorine. Remember, the anion, the ending is going to be changed. It's not going to be chlorine. It's going to be changed to chloride. So you look up chlorine. So see if you can find that in the periodic table. Chlorine is element number 17, and it has a symbol Cl. Okay. The next step with ionic compounds, if you're trying to figure out what the formula is to determine the charges. Now, in the previous sample problem, 2.4, we talked about how that Roman numeral 1, capital I, represents the charge of the ion, of the metal ion. So the fact that that's a 1 means the charge is plus 1. Now, when the charge is 1, people usually just put the symbol there. So we wouldn't write plus 1, we just put plus. If it were plus 2, then we would put plus 2 or 2 plus, either way. But if it's only a charge of 1, you just put a plus symbol. The next thing to do is to figure out what the charge of chloride is. This is the general strategy you use. If you look in the periodic table at column 7A, that's where you'll find fluorine, which is element number 9, chlorine, which is element 17, bromine, which is element 35, iodine, which is element 53. All of those elements, when they are part of ionic compounds, so if chlorine is in an ionic compound, if bromine is in an ionic compound, they all have the same charge, -1. Okay? So memorize that. Column 7A, when you're dealing with ionic compounds, each of those elements has a charge of -1. And when we write -1, we just write minus. Okay? Now what you do is you match up the charges. If the charge of the cation is equal to the charge of the anion, then they combine in a 1-to-1 ratio. And so we write it as HgCl. Okay? If the charges have the same magnitude, +1 -1, or +2 -2, or +3 -3, then they will combine in a 1-to-1 ratio. So all we have to do to write the formula of the compound is just to write the symbols next to each other. This would be the formula for mercury 1 chloride. Let's look at the second one, part B. This one's more complicated because of the anion. It's lead 2 chromate. So you look up the symbol. Lead is element 82. It's way in there, way deep in the periodic table. Element 82. PB for plumbum. Plumbers use lead. So that language is still in there. That's the Latin form of lead. We use that symbol just like we do for mercury. Chromate, however, is not like chloride. It's a polyatomic ion. So you have to figure out what the formula of chromate is. I recommend you memorize them. They're in this section in the textbook. The chromate ion is CrO4 minus 2. Traditionally, we write the number of the charge and then the symbol, 2 minus, as opposed to minus 2. Okay, what about lead? Well, it says it's lead 2, II, so that means it's plus 2. Again, you write the number, then the symbol. As I said with mercury 1 chloride, if the charges are the same magnitude for the cation and the anion, lead is plus 2, chromate is minus 2, then they will combine in a 1-to-1 ratio. So all you do is you write down PbCrO4. With ionic compounds, the charges are not shown. It would be incorrect to write Pb2 plus CrO4 as considered poor form. You do not write the charges in the formula for a compound. Let's look at part C. Part C says potassium. This one actually seems to have 3 parts, right? Potassium, hydrogen, phosphate. Interesting name, right? Okay. If you look at column 1A in the periodic table, you will find hydrogen, lithium, sodium, potassium, rubidium, and cesium. Okay. All of those ions in ionic compounds have a charge of +1. In a sense, they're the counter to the halogens group 7A. 7A, all of those ions are -1. 1A, they're all +1. Memorize those charges. Potassium, hydrogen, phosphate. Potassium, the symbol for it is a K for kalium. Has charge +1. Hydrogen has charge +1. Phosphate has charge of -3. In fact, this together is called hydrogen phosphate. And it's considered a polyatomic ion. I didn't spell that right, phosphate, okay? Hydrogen phosphate is HPO4 2-, and it's a polyatomic ion that's formed from the hydrogen ion and the phosphate ion, but it's called hydrogen phosphate. So now, think of this instead of being 3 ions, just think of it as being 2. K plus HPO4 -2. Okay, now the charges are not the same magnitude. Potassium has a charge of 1, but hydrogen phosphate has a charge of 2. So what you do is you find the lowest common factor of those 2. And the lowest common factor is 2. 2 and 1 is 2. Okay. You just take +1 and you multiply by -2, you get -2, right? So what we do then is we say the following. How many potassiums does it take to get a charge of +2 to match the charge of the hydrogen phosphate? Well, if each one is +1, it would take 2 potassiums. So we write it as K2H2O4. Again, you do not write the charges in the formula. This is all written together. I didn't put much space there. I mean, I put some space there. I don't want to mislead you into thinking that we write them separately. They're actually written right next to each other. K2 is one formula. This is called a formula, a secret formula. Potassium hydrogen phosphate. So how did I get the 2? What I did was I said, hey, this is -2, but this is only +1. So we need 2 of these to match the 2 there. Essentially, the idea is the following. If you have a charge of +2 and you're going to neutralize it with charges of +1, you need 2 of the +1s. I'm sorry, if this is a -2. If you had an ion that had a charge of -3, you would need 3 of the positives, right? So you'd have K3, 3 positives. Phosphate is -3. So that would give you K3PO4. So there you go. So that would be your formula. K2HPO4, potassium hydrogen phosphate. The hydrogen phosphate is actually one polyatomic ion, even though it has 2 words in it.